So Mod 6 is about rational functions. So I wanted to start out 6.0 kind of reviewing those rules of factoring and then looking at equations, and then we'll start breaking down what the graphs look like. So I kind of wanted to do it in this order, for that reason. If you take a look at these are just equations, but you see they have lots of fractions in them. Okay. Now, the thing we have to be concerned about is if we have our variables, you'll notice we got variables in our denominators. We have to talk about something called an extraneous solution. So what are some values that could mess it all up? And so we'll account for that as we go through the process, okay? So we're going to do the evens this time. You'll be responsible to do the odds by the end of today. Let's start with problem number 2. Now, to solve an equation like this, I think the first thing we want to deal with is let's get rid of the fractions. Anytime I see an equation with fractions in it, let's get rid of the fractions. So what you want to do is you want to find that least common denominator. Excuse me. So our least common denominator for this one, you will need to account for the numerical part. There's a 2 I see in our denominators. And then our highest power of our n, which is an n squared. So our least common denominator is 2n squared. Now, that least common denominator, since it's a denominator, 2n squared is not allowed to equal 0. So let's just take a minute and figure out what values of n does that occur. Well, if you divide both sides by 2, you get n squared equals 0. And then if you take off the square, you got a square root 0, you still get 0. So we know that our extraneous solution, if it occurs, would occur at 0. But other than that, we're going to set that to the side for a moment. And all we're going to do is we're going to multiply every single one of these fractions by that least common denominator, 2n squared. Now, to multiply a fraction times a non-fraction, if it helps you to put that thing over 1, to remind you that you're just really multiplying the numerators by 2n squared, go ahead and do that. Now, we're going to distribute that because as long as we multiply every single thing by 2n squared, then we don't change the value of the n in the equation. So if we multiply this one, 1 times 2n squared is 2n squared. If we divide off the n squared, that piece would be reduced down to 2. Here, if I multiply here, 1 times 2n squared is 2n squared. Divide that by n. Now this time, only one of the n's is gone, so we'd be left with a 2n. And then 2n squared times 1 is 2n squared. 2n squared divided by 2n squared, they cancel perfectly, so we're just left with 1. So look at how much easier we have of an equation to solve. When you first look at that equation, that's like, what the heck? That's disgusting. But if you multiply through by that least common denominator, you're going to quickly make your equation so much nicer, okay? So identify the least common denominator, use it, do your work. Now that's just an equation. We're going to subtract 2 from both sides. We're going to divide by 2. Now always compare what was the extraneous solution, what was our actual solution, and then as long as those two things don't match, that's our answer. Okay. So it's not a hard process if you use that common denominator to your advantage. Do we have any questions about number 2? So this is 6.0. We started yesterday. It's the 3rd page, okay? Okay, let's do the same thing now for problem 4. Now, we have a few more pieces and parts to deal with here. Any numerator that happens to have more than one term in it, put some parentheses there. That's just going to help us that we don't do something funky. Okay. We still need to find that least common denominator. Our least common denominator The least common multiple of 4 and 2 is 4. Your highest power is a squared, so that would be 4b squared. 4b squared, remember, is not allowed to equal 0. So b is not allowed to equal 0. So if we get a value of 0, we do have to throw that out. It just doesn't work. So we're going to surround this entire thing by parentheses. Put a little dot out here. We're going to multiply everything by that least common denominator. Now, really, technically, it's over 1. So really just our tops are going to multiply by 4b squared. So if I multiply this top by 4b squared, the 4b squares cancel out perfectly. So I'm just left with b plus 6. If I multiply this top by 4b squared, 2b squared, and 4b squared, the b squareds cancel, but 2 goes into 4 2 times. So it would be left with a 3 times 2. Now, you could have just made it a 6, but I'm just kind of showing you the steps. So, and then same thing kind of happens for this one. 4b squared would sit next to this one. 4b squared and 2b squared. Everything would cancel out, but you would be left with a 2. So the reason I like the parentheses is that reminds me to distribute into the b plus 4. So if you don't have the parentheses, you might have the tendency to put the 2 next to the b, and that would mess things up. So I would suggest kind of writing it like that to start with. Our first parenthesis had nothing with it, so you can just drop the parenthesis off. 3 times 2 is 6. Here we have to use the distributive property, so we get 2b plus 8. Now, before you start moving things around, I would suggest that you get to each side as simplified as possible. So let's make this b plus 12 equals 2b plus 8. You can move the b's to whatever side you want to. I'm going to move it over here, so then I'll get a positive b. No big deal, but it will make that really nice. If I put the b's to the right, that means I need to get the number over to the left. So you're just shuffling the equation so you can solve for b. And I get that b is equal to 4. Now, if we compare that with our extraneous value, our excluded value of 0, we don't have to worry. 4 is not equal to 0, so that one works. Now you could check it. You could put 4 back into the original equation. You should get a true statement if you plug in 4. So that is number 4. Let's do number 6. So our numerical components on the denominators, 6 and 2, the least common multiple of that is 6. And our highest power is a square. So let's surround that by parentheses. Let's multiply by 6x squared. Now remember, that's really over 1, so really only our tops are being multiplied by 6x squared. Our numerators get multiplied by 6x squared. Now remember, 6x squared is not allowed to equal 0, so x is not allowed to equal 0. And that's going to happen quite often until we get to one like number 8, so expect 0 might be a thing. Okay. When we multiply through here, the 6x squareds are perfect matches. 6x squared divided by 6x squared is 1. So you're just left with a 1 times 1 or 1. 6x squared times 1 is 6x squared. The 2x and the 6x do have to reduce down a little bit. 6 divided by 2 is 3. We have an extra x in our numerator. Let's do it again. 6x squared times 7. The 6x squareds are a perfect match, so they cancel out to become a 1. 7 times 1 is 7. So it becomes a much simpler equation at this point. If you subtract 7 to both sides, you get negative 6 equals 3x. Divide by 3, x equals negative 2. That is not the extraneous solution. So we don't have to worry about 2, negative 2. Negative 2 is our solution. Now, when we start to get to problems like 8 and 10, you do have to factor these first. So we do have to get these in factored form. So that's kind of why we did the lesson we did yesterday, practicing breaking that fractions apart into factored form. So before we decide what our least common multiple is or anything like that, let's take our denominators and let's break them all apart. Okay, now what do I mean by that? Well, our first fraction, our denominator has a greatest common factor of m. And if I factor out an m, I'd be left with an m minus 1. Now, the reason that you have two terms here, if you distribute, you better get m squared minus m. You have to have that 1 there as like a little placeholder. And then there's nothing I can do about that one. And then the same factorization holds for the last fraction. That would be m and m minus 1. Now, why do that? Well, that is going to help us find our least common denominator. The only factors I see throughout the entire process is an m and an m minus 1. Keep those separated, because finding our extraneous values is going to be a little easier that way. When we go to multiply and cancel stuff out, it's going to be easier. There's just a variety of ways that factored form is very helpful. So I know m is not allowed to equal 0. M minus 1 is not allowed to equal 0. So this one, we have two values to be concerned about. 0 doesn't work. It gives us a weird 0 denominator. 1 doesn't work. It does the same thing. So those two values, if we do our math and we get values of either 0 or 1, cross it out. They don't work. Okay. So now let's revisit our actual problem. Surrounded in parentheses. Over to the side, multiply by the least common denominator. So we need an m and an m minus 1. Now, technically, remember, that's over 1. It's only going to be up on the top where we're actually going to physically multiply. And we're not going to multiply per se because the denominators are going to cancel. Okay, so let's look at our first one. M and m minus 1 are going to sit right here. Okay, what does that mean for our first fraction? Well, the m's are going to cancel. The m minus 1s are going to cancel. So what are we left with? 1. Okay. Let's look at this one. When we distribute to this fraction and that sits up top, the only thing that's going to cancel is an m. We're going to be left with a 1 times m minus 1. Now, if you just know that 1 times m minus 1 is m minus 1 and you wrote m minus 1, go for it. I don't care. I'm just kind of visualizing, showing you everything. In this piece, if it's sitting there next to the 5, the m's are going to cancel. The m minus 1s are going to cancel. The only thing left would be 5 times 1, or 5. And now it's just an equation. We have 1 plus m minus 1 equals 5, so m is equal to 5. Now, always compare that to our extraneous values. 5 is not 0 or 1. So 5 works just fine. That is our answer. We are solving for the m that works. We have just solved for the m that works. Yeah, that's as far as we go. The value of m that makes that equation true is 5. We just solved the equation. The answer is 5. Yep. Every single time we have been, let's go through the process. We have been multiplying through by the common denominator, getting a much simpler equation, and that's the one we get to solve, and that solves the answer, solves for the answer. That's as far as we have to go. Yep. We did, look. If you distribute the 1, you get m minus 1. And then the ones that happen to cancel, and so you're just left with m equals 5. Yeah, it just worked out that way. Okay, let's do number 10. We have to get this into factored form or it doesn't work. Okay, so this one, just write it like this. Put all your factors, your binomials, in parentheses. The factors of 10 that will add up to 7 are 2 and 5. So this is going to be r minus 2 and r minus 5. Let's identify our least common denominator. Our least common denominator has to contain an r minus 2 and an r minus 5. That means that our excluded values occur when r minus 2 equals 0. That's not allowed to happen. And when r minus 5 equals 0, that's not allowed to happen. So our excluded values for this one are 2 and 5. So now that we know that, surround your entire equation by parentheses. We're going to have to multiply by r minus 2 and r minus 5. Let me scooch this over a little bit. Okay. So what happens when we do that? Well, really, remember, you're multiplying by the tops. Okay. So if I multiply this on top here, the r minus 2's kind of get scratched out. They're gone. So we're just left with our r minus 5. In this particular one, if it's sitting there, the r minus 2's we get to scratch out. The r minus 5's we get to scratch out. We are just left with a 1. And then if we do this one, the r minus 2 scratched out, we are still left with a 6 and an r minus 5. Now that's just an equation. If I gave you that equation, said solve for r, that's all you're doing at this point. So we get r minus 5 plus 1 equals 6r minus 30. We need to move stuff around. Let's make this an r minus 4 before we begin that process. I see I have more r's on the right. It doesn't matter. You decide. It's not going to hurt anything. But I'm going to take that r and move it to the right, which will make me move the 30 to the left, if I'm consistent there. And 30 minus 4 is 26. 6r minus r is 5r. I'm just making sure I didn't do anything funky. I think I'm okay. If I did do something, let me know. But anyway, we're going to now just divide by 5. So r is 26 divided by 5. Now, if we compare that with our excluded values of 2 and 5, that's not an excluded value. 26 over 5 is just our answer. Leave it alone. That is what it is. Okay. So that is, oh, here's, no, I'm just checking to make sure. Normally they come out a little nicer than that. Okay, anyway, that seems okay. So that is problem number 10. Let's look at problem number 12. We don't care what is in our numerator at this point. I would suggest putting that in parentheses. Other than that, we don't care. The only denominator I see, because technically that's over 1, the only denominator I see in this process is 5r. So that has to be my least common denominator. And remember, that is not allowed to equal 0. So r is not allowed to equal 0. So that's what I know right off the bat. So I'm going to surround this by parentheses. I'm going to multiply by 5r. Now remember, technically that's 5r over 1. So only my tops are getting multiplied by 5r. When I multiply and set it next to the top on this one, the 5r's are a perfect match. They cancel out and just leave a 1. 1 times r minus 4 is r minus 4. When I multiply this one, same thing kind of happens. The 5r's cancel out. 1 times 1 is 1. And then when I multiply 5r times 1, it's just 5r. And now it's just an equation. Solve it. Okay. So to solve it, I'm going to subtract an r from both sides. I'm going to subtract a 1 from both sides. I get 4r is equal to negative 5. So r is negative 5 divided by 4. That's my answer. It is not the excluded value. It works just fine. So that is my answer. Many times for these, you do get fractional answers, and that's okay. There's nothing wrong with that. Everybody okay so far with these? Do we have any questions or concerns? Yes.
So just checking, because I think I sort of get it by now, but the least common denominator is just all of the denominators that show up.
Yes, exactly. Yes. So your least common denominator, remember, is just the least common multiple that everything that you see in the denominator can go into. So treat the numbers like normal. Like if you saw 2 and 3, I need a 6. And then your variables or factors, you need the highest power to show up. Yeah. Let's look at 14. Now the problem with 14 is its denominator is not in factor form. So before I decide what my least common denominator is for 14, I need to factor all of my denominators. And I try to put any binomials and things like that in parentheses. So my least common denominator for this one, I need an x and I need an x plus 2. That's kind of what we were talking about a second ago. We need each of the things to appear in our least common denominator. That means our excluded values are 0 and negative 2. So if we do the process and we get an answer of 0 and negative 2, watch out. We're going to throw those ones out. Surround your equation with parentheses. We're going to multiply by x and x plus 2. Now, on the left side here, we just have a whole number 1. So it's just 1 times that junk. So 1 times anything is just itself. Now you can actually physically distribute at this point if you want to. We're going to do that in a second. When we multiply this on this fraction, the x's cancel, the x plus 2's cancel. We're just left with 1 times 1 or 1. When we get to this part and we distribute for this thing, the x's cancel. But the reason I like to write parentheses is if you keep it in parentheses, you'll clearly decide what algebra comes next. If you don't have parentheses, I've had people write it weird, and so then they end up making mistakes. Parentheses are helpful. Okay. Now, from here, we have some things to do on both sides. On the left side, distribute. On the right side, we have to distribute these two things. If you distribute that, and you FOIL it, and you combine it, just to save space on my part, this would be x squared plus x minus 2. Now, you technically get 3 terms, but I know the rules that I kind of combined them so we in one spot. But if you want to distribute this times this and this times this, you can. Now, I notice that there's an x squared on both sides. That happens many times, and not often, but sometimes. And what's great is if we subtract x squared from both sides, we don't have a squared anymore. If you end up with a squared in your problem, it's a quadratic. You got to use the quadratic formula or factoring. This one, it cancels out pretty nicely. And then let's subtract an x from both sides. And then I think we'll get our equation ready to go. 2x minus x is x. So the only thing I haven't dealt with are these two numbers right here. Well, 1 minus 2 is negative 1. Now again, I know we haven't run across any where this has been an issue, but it still might be. So if we compare, negative 1 is not on our excluded values list, so negative 1 is just fine. So there's problem 14. Let's do 16. I see some things I need to fix. Let's get everything in factored form. In the bottom, I can remove an r from both pieces, leaving me an r minus 2. So my least common denominator is r and r minus 2. So r is not allowed to equal 0, and r is not allowed to equal 2. So surround it with parentheses, multiply by r and r minus 2. Now our first fraction, that is our denominator. So they are perfect things to cancel out. I'm just left with r plus 5. Now our second fraction, there is nothing sitting there but a negative 1. So let's write negative 1 times r. Well, let's do it like this. Negative 1 times r is negative r times r minus 2, just so then we can kind of mush it together. So we don't have a negative 1 sitting next to an r. Negative 1 times r is negative r. And then this fraction, both cancel. I'm just left with a 1. Now this is one where an r squared is going to appear in our equation. Let's multiply it out. Let's see what the heck happens. So we get r plus 5 minus r squared minus 2r equals 1. Now our highest power is an r squared. So it's a quadratic. We got to solve it using what we know about how to solve a quadratic. I don't like when my r squared or highest power is negative. So let's move everything to the right. We'll get it equal to 0, and we'll also change that fact. So I am going to take this off. I am going to take care of that. And then I got to move that. So however you want to do it. Because I want that side to equal 0, because I can't really solve a quadratic unless it's equal to 0. Excuse me. So we get r squared minus r plus 2r is plus r. 1 minus 5 is negative 4. Okay, now all of that, let me make sure I actually did all that mess right. I did not. This is hot. A negative times a negative. Oh, it's a positive. Which makes that, I'm so sorry, I could. R squared plus 2r, which would make that a minus 2r, which would make that a minus 2r. I knew I had a mistake. I'm like, they probably didn't make it that disgusting. I get 0 equals r squared minus 3r minus 4. There we go. It's factorable. Like, oh, please let it be factorable. Anyway, you can at this point solve it with the quadratic formula. Remember, if factoring is not your friend, feel free to use the quadratic formula. That factors to be r minus 4 and r plus 1. So we get values of positive 4 or negative 1. Both of those are not on my excluded value list. I know I keep talking about that excluded value list. We haven't really had to use it, but don't think that that's something that doesn't happen. I just want to keep reminding you that that could be a thing. Okay, so that is problem 16, where we actually have two answers that make that equation true. So kind of weird when that happens. Okay, 2 more to go. Let's look at 18. Let's surround everything with parentheses. I kind of got carried away with my parentheses. Our denominators are a plus 3 and a plus 2. So our least common denominator has to include a plus 3 and a plus 2. So a can't equal negative 3 or negative 2. Negative 3 and negative 2 both make that equation not work. Okay. So surround your equation by parentheses. Over here on the side, we're going to multiply by a plus 3 and a plus 2. Now, when we do that, this first fraction, the a plus 3's cancel. So we're left with a minus 2 and a plus 2. This piece is going to multiply by that negative 1, so just sit it next to a negative symbol. We'll take care of that in a minute. This piece next to the 3, the a plus 2's I don't need anymore, but I do need the a plus 3. So we got that. Now, to solve this, we do need to do some multiplication. If we were to FOIL this first piece, we get a squared minus 4. That's the difference of squares. That's great when they're conjugates like that. Use your parentheses for a moment here. In this piece, we do have to FOIL that out. If you were to do the whole FOIL process, you do get that 4 terms, but they do combine to give you a squared plus 5a plus 6. And then we can distribute here. And if I make any funky mistakes, please let me know. Now, the parentheses were helpful to identify that we are subtracting. So let's multiply that list by negative 1. So we get a squared minus 4 minus a squared minus 5a minus 6. Now, some really nice things happen on the left side. And this happens more often than you think for these. The a squares are opposites. They do cancel out, which is great. These are like terms. We can combine those. So let's make our problem say negative 10 minus 5a equals 3a plus 9. Now it just looks like a normal equation. Let's get our a's to one side and numbers to another. So I'm going to add 5a to both sides. I'm trying to get my a to the right, just so it's positive. It doesn't matter. Which makes me make this negative 9 go to the other side. So we get negative 19 equals 8a. And then we just divide. We got our answer. So a is negative 19 divided by 8. That is not on our excluded value list. That's our answer. So that is problem 18. It is very easy, and you know I'm great at it, to make a little mistake on these. So please be very careful, show your steps, work through the process. Okay. Last one, and then you'll have the rest of class to work on this. This is due tonight by midnight. Okay, let's look at 20. The denominators are not in factor form. So this denominator is the only one that isn't in great form. They both contain n's, our lowest power squared. So take out an n squared. So our least common denominator has to contain an n squared and an n plus 5. That will cover everything we see there. Even though the other pieces have bits and pieces of it, that still is kind of everything we need. So our values to avoid are 0 and negative 5. So those are our values that we have to throw out if we get one like that. We haven't once, but yeah, you never know. Okay. Surround your entire equation by parentheses. On the side, note we are going to multiply by n squared and n plus 5. Now you can do this trick whether or not your denominators are containing variables or if they're just fractions of any sort. If you multiply an equation through by the common denominator, you don't have to deal with fractions until the very end. So it's always a good trick. I even do it even if I don't have ends, but if I just have fractions in general. Okay, if I multiply this here, it's a perfect match. So it just leaves me a 5. When I multiply by this fraction by the 4, the only things that cancel out are the n plus 5. So I'm left with a 4n squared. When I multiply here, the n squares cancel out. 1 times n plus 5 is n plus 5. Now, that is a quadratic. I don't like the fact that it's not equal to 0, so I'm going to subtract 5 from both sides, which leaves me actually a 2-term quadratic, which is a good one because in this case, it is factorable. You can take out an n from both terms. So how do we solve a quadratic like that? Well, a factored form quadratic equation is solved very nicely. Either our first factor could equal 0, or our second factor could equal 0. Now the first one's kind of solved for us, n equals 0. But here we have 4n equals -1, so n equals -4. Now for the very first time, if we compare these answers to our excluded value list, one of them is on the list, right? So when that happens, cross it out. I cross it out and then I kind of circle the one to remind me, hey, that's the one that works. The other one does not. So our answer is -1/4. Okay? So, you are getting to the point where, we are trying to get ready for a calculus class if you ever take calculus in your future. Complicated equations are a thing. You need to be able to know how to manipulate and solve them. And so, we've done lots of little tricks. I try to show you those little tricks as we go. So now your job is to finish this worksheet. You're going to finish the odd ones by midnight tonight. Use your class time wisely. Do it right now. When you're done, even though those first 2 sheets, the first 2 pages are attached from yesterday, I don't care. Feel free to turn in the whole document. I believe the answers are at the bottom, so you can check your work if you want. But you got to show work because obviously you can tell these take a lot of step-by-step solving. Okay, so there you go. Use your time wisely, and that's it.